Hello everyone, today we're going over 2.1 functions. Do you know what is the meaning of function? Anyone has the idea for functions?
Good morning, Professor. Professor, I have an appointment. I have to leave at 11 today.
11? Okay, no
Yeah.
problem. It's fine.
Okay.
Okay. Do you know what is the meaning of
function is a relationship or expression involving one or two or more variables.
Exactly. It's a relationship between two sets, I can say. Anyone has another idea about function too?
A function is a function of something that has a does not have a repeating x value.
It does not repeating the x value. Is not like a perfect define for the function. I can say the function if is like a rules, or I can say the function is look like a machine, like this. This is my function. Okay. So I can say it is a rule, or it's a machine like this. It has an input and output. So the function has input and output like this. This is my input. And this is my output for the function. This look like a machine. And here is the f. This is mean f is a function. And this is my machine. The input here is like values. Sorry for that. Connection was bad. Okay, let's go back again. Like I said, the function is a machine, has input and output. Can you hear me clear?
Yeah.
Okay. Thanks. So again, it's a machine has input and output here functions. Two point one. Again, it's a function like this, machine. The function like this, is it a machine? Has input and also has output. This is the input here. And this is the output. So the input like this. and this is the output. So the input, it's a value like x, comes here, and the output is f of x. And if the function f, the function named by f. So the input x goes inside the machine, then the machine do it f of x, output. So input, here output. And this is machine. So x belongs to set called A. Here I can say this x, this value is taken from set A, and this value of x is coming from set called B. Okay, so every input, we have to know also, every input has only one output. Every input has only one output. Every input has only one output. This is very important. I mean, for that, we cannot plug one input and does not give me two output. Every input has only one output, does not have two output. So I can define the function in math as here, function, a function is a rule that assign to each element x in a set A exactly one one element in a set B called f of x. So this is the definition of a function. A function f is a function is a rule. Here, function f, I will call it f by letter f, is a rule that assigns to each element x in a set A exactly one element in a set B called f of x. So the question is now, what is A and what is B? What is the mean of A and what is the mean of B? Or here I said each element x is taken from A, exactly element f of x belong to B. So the question is now, what is A and what is B? So what is A and what is B? Any idea what is the mean of A? What is the set A? And what is the set B here? Same x value cannot be with two different y values. No, this is not correct. The same x value cannot, yes, it cannot be. Yes, cannot be with two different y value. Every element, every x, take one y or take one f of x. Not every x take two different element in the set B. I mean, every element x from the set A take only one value from the set B. So the question is now, what is A and what is B? Have you heard about domain and range? So the set A is the domain of the function, and the set B called the range of the function f. So here I can say A is the set of the domain, and B is the set of the range for the function. So this is the mean of A and this is the mean of B. A is the set of the domain and B is the set of the range of the function. So now my question, what is the domain? What is the mean of domain?
It's the independent variable x.
It's independent variable x. And what do you mean like, okay, this is in math, but now my question, like in general, what is the mean of domain, like for the function? Like in general, what is the mean of
Input.
domain? Input, okay, this is correct. But I can say any input or like possible input for the function. Because some value I cannot put it in the function, it will not define. I cannot plug it in the function. So I can say here the domain is a set of all possible inputs, not any inputs, the possible for the function, the values that I can plug it inside the function. So the domain here, domain mean all the set is a set of all possible inputs. All possible inputs called domain. And also the range. What is the mean of range? Any idea? The same like
Of all possible outputs.
exactly is the set of all possible output. So the possible input called domain, possible output called range. So now we get the idea about the function. What is the mean of function? Also we get the idea for the set A and the set B, domain and range. Also we define like what is the mean of, I give the definition, not the definition, the general idea about the word domain and also the word range. Okay, so also we have another way to picture a function. So we're not going to use the machine. The machine is like the general idea about function, but we're going to picture a function by a row diagram. So the row diagram, we're going to talk about this one. Here's the row diagram. So another way to picture a function is by a row diagram. Okay. I will show you what is the mean of the row diagram, what I mean for the row diagram. So my example from the example. So my example now, my example, which of this two diagram satisfy to be a function. First diagram is look like this. This is my first one. My second one is look like this. Second one is like this. So the first one has some values like this. Here, 1, 2, 3, 4, 1, 1, 2, 3, 4. And here we have 30, 60, 80. 1, 2, 3, 4, 30, 60, 80. And also in the other way, other one, we have 1, 2, 3, 4. 1, 2, 3, 4. And here we have 30, 60, and 80. One, 2, 3, 4, 30, 60, and 80. For the first diagram in this one, in the left side, number 1 goes to here, to the 30. And number 2 goes to 30. Number 3 goes to 60. And number 4 goes to 80. And for the second diagram, number 1 goes to 30. Number 2 goes to also 30. And in the same times goes to, the first one goes to 30 and here goes to 80. Goes to 80, 60 I mean. Number 3 goes to 80. Okay, for the first one, this is represent a function.
Yes.
Yes. Is every input has take exactly one output?
Yes.
Yes. Look to the one, take 30. Number 1, take output 30. Number 2, take 30. Number 3, take 60. And 4, take 80. So every input take only one output. So I mean here, number 1 take 30 and 2 take 1 take 30, 2 take 30 and here. So 1 take 30, 2 take 30, 3 take 60 and 4 take 80. So actually every input take one output. So this is represent a function. This is correct. Here, yes. It is a function. Why? Because every input take exactly one output. This is represent a function here in the second diagram. Does the second diagram represent a function? Is every input take out one output? Victoria said no. Can you explain why no? Can you explain?
It's because the same x value has two different outputs or two different y values.
Which value
Two,
take?
2 is with 30 and 60 at the same time.
Exactly. And look to the 4 also. The 4 does not take any value. This is not a function too. Here, every input, I mean, now one should take value, take exactly one output. So number 4 does not take any output. This is the first reason is not a function. Second reason, number 2 take 2 output. So also this is not a function. So here the 1 take 30, 2 take 30 and 60. Also the 3 take 80. And number 4 does not take anything. This is wrong. Every input should take an output and take only exactly one output, not 2 output. So here I can say, no, this is not a function. No, not function. Because I want to put here, because the 2 takes two values. And 4 does not take any value.
Mommy?
Not take any value. This is the reason. 2 takes 2 values and 4 does not take any value. So this is not correct. That's why this is not a diagram for function. Any question here? Makes sense? Okay, now we have example. Function defined as, we're going to define the function and evaluate some point. So here, example number 2, a function f is defined as f of x equal x squared plus 4. A function f is defined as f of x squared equal f of x squared plus 4. So the first question, number 1, evaluate f of 3, f of minus 2, f of square root of 5. Square root of 5. This is number 1. Number 2, find the domain and range of f. Number 3, draw a machine diagram for function f. Evaluate f of 3, f of minus 2, f of 5, Find the domain and the range for the function f. Draw a machine diagram for f. Who will do the first one? Evaluate f of 3. Number 1. What is
I-
f of 3?
I would-
When I plug the 3.
10.
Yes, here I ask, those points were picked random? Yes. I pick a random point and I would like to plug it inside the function to check the value. For
It's
each
easier
of
to
them.
make a table, right?
You can make a table, but or you can like plug it right away inside the function. Just plug the 3 inside the function and get the value. What is f of 3?
10.
How you do? How you find it? How you get the 10? What you
I
do?
j- oh, sorry, not 10.
Okay.
3 squared is 9 plus 4 is
Okay.
13.
Okay. 3 square plus 4. 3 square is 9. 9 plus 4 is 13. Correct. Who will do the second one?
Me.
Yes, go
Yeah.
ahead.
So minus 2, right?
Yeah,
So
f of
minus 2 squared
Equal-
is 4 plus 4
Okay.
is 8.
minus 2 square plus 4.
And
What is the value for minus 2 square
4,
plus 4? What I get?
8.
Exactly. Thank you. Third one,
You're
of the square root of 5. What is f of square root of 5?
It's 9.
How you find it? How you get the answer?
When you substitute square root of 5 in square root of x, the square roots cancel.
Okay. So
And then-
actually get 5
Plus 4, which is
plus
9.
4. Okay, thanks. This is correct. So the first one, the first question is done. Now, second one, find the domain and the range for the function f. The domain is all possible input. What is the possible input for the function f of x?
At 3. Wait,
What is all possible input? I can plug it inside the function and the function will stay defined after I plug the number you choose.
Is it all real numbers? Because I think literally everything works.
Exactly. So if I plug any number, all the numbers I plug will work fine. So I plug 3 negative numbers like minus 2 will give me a value. If I plug the 0 here, they will give me a value. If I plug positive number, 1, 2, 3, 4, any number, I will get output. So if any number I plug it, they will give me one output. So this is mean the domain will be all real numbers. So here I can, the domain, can say here. So again, to check what is the domain, you have to check any negative numbers or most of the negative numbers, check the 0, 2, check all or any like some random point of the positive numbers. So when I plug here positive numbers, the function will be defined. If I plug the 0, they will be defined. They will give me a value. If I plug negatives here, will be also defined. So here the domain will be all real numbers. So the domain, I can define it, domain, all possible input, and here my possible input, all real numbers. So domain here, the domain. And this question, in this example is R. R is mean the real numbers, all real numbers. What is the range?
is it also all real? Possible?
I mean for the range, all possible output. So in this function, if I'm looking for this here, f of x equal x squared plus 4. If I plug, for example, 0, what I'm going to get here?
4.
4. If I plug positive starting from 1, so f of 0 here, they give me 4. F of 1, like positive numbers, what they give me? 1 squared plus 4 is
It's a
5.
positive number.
Exactly. F of 2, 2 squared is like 4, and 4 plus 4 is 8. So it goes up, like they will give you more positive numbers, 5, 8. If I plug also 1.1, for example, 1.1, they will give me a positive numbers. But this positive number is greater than 4. The positive number, they will be greater than 4. Now, if I plug negative numbers, starting from f of 0, f of minus 1, what they will give me? What's the answer?
It'll be a positive number, 5.
5 again. What about f of 2 minus 2?
It's going to be a positive value because you're squaring it. It's always going to be a positive value.
Exactly. 8. So this is mean all possible output starting from 4 and above. Because here, if I plug any number inside this function, they will not give me 3. Or they will not give me like negative numbers as output. Or also they will not give me 0 as output at all. So the output for this function will start from 4 and goes up from 4 to infinity, positive. So all possible output for this function is from 4 to infinity, positive. So the range all possible output.
In the test, can they ask you a question like this? What is the domain? What is the range?
Yes. But it will be like easy and simple and direct like this. Just plug numbers positive and check. Plug the 0 and check. Plug negatives like this and check. The range is all values starting from 4 to infinity. Or I can define it in different way, is y such that y greater or equal than 4. Any question? Any question for this example? For the second part of the example and first part also?
When they ask you what is the domain range, can you just write, for example, the domain is R, or do you have to write all possible input?
Yeah, you can write R as this is the answer for the question. The domain is R. You don't have to write all possible input. All possible input is the definition for the domain, or like the idea for what is the meaning of domain. But the answer is R. The answer is the real numbers R. Here the answer is the closed interval from 4 to infinity, or y such that y greater than or equal 4. Okay, Ahmed.
Yeah, thank you.
You're welcome. So number 3, who'll do? So the number 3, draw a machine diagram for f. So we're going to draw a diagram like this. symbol like this. But the f here, we're going to write the name for the function. Here, the output, we're going to specify what is the output. Here, the input, we're going to define what is the value for the inputs. Okay, I'm moving to the next slide. Here, it's not work. Okay. Okay. So next slide. Here is the third question. Here, draw a diagram. So 3. So the diagram will be look like this. Like this is a machine, and this machine has input like this. This is the input, and this is the output. So of x equal x squared plus 4. Here is the output is f of x. Here's the input is x. The input here will be x belong to the real numbers. The output here is f of x belong to the set from 4 to infinity. So this is the input here, output. Here machine. Okay, any question? Any question for the diagram? Okay, now more example for how we can evaluate. So the second example, f of x equal 3x squared plus x minus 5. Three x squared plus x minus 5. Now the question is evaluate each function. Evaluate each of f of minus 2, comma, f of 0, f of 4, and that's it. Who will do the first one? F of minus 2.
Me.
Yes, go ahead.
So 3 times minus 2 square plus
Okay.
plus minus 2. It will be minus 2 and minus 5.
Okay, let's do it together. Minus 2 equal 3 times minus 2 square,
2
like
square.
you said,
Yeah.
plus minus 2, okay,
Yeah.
plus
And minus 5.
minus 5. Okay, what is the answer?
So it will
3
be
times
minus
4.
6. Oh no, it will be 3
4
times minus 4, minus
minus
2,
2 minus 5.
and minus 5.
No,
It's
3 times
12.
4, it's 12. Okay, go
12.
ahead. Okay,
Minus 2, minus 5. It
and the
will be
answer
10
is
minus 5, and it's 5.
5, positive 5.
Yeah.
This is correct. Thanks. For the second one, f of 0.
Is that a square on top? 3x squared.
Where is it? Oh, yeah. See this one? 3x squared, yes. 3x squared plus 5 minus 5, plus x minus 5.
It's just minus 5 there.
It will be minus 5. This is correct. 3 times 0 square plus 0 minus 5. Here will be 0 plus 0, 0 equal minus 5. Okay, for the last one, f of 4. What's the value? 3 times what?
3 times 3 is 9 plus
3
3, 20,
times 3 times 4
27.
squared, right?
4.
We plug the 4 inside the function. So
Oh,
3 times
4.
4, yes,
Right.
plus 4 minus 5. What I get? Shop.
You get
Eric said 47. Let's check. 4 squared is 16. 16 times 3 is
16 times 3 is 48.
is
Is it?
48. 16 times 3 plus 4 minus 5. 4 minus 5 is minus 1, and here I get 48. 48 minus 1, I get 47. This is correct, Eric. Okay, this is correct also, Shop. Now, we're going over piecewise function. Piecewise function. Now we have different kind of function called piecewise. Functions or function, piecewise function. I mean, for piecewise function is a function defined with two rules. I mean, for two rules, something like this, I have c of x, this is my function, equal is defined as 39 and also 39 plus 15 times open parentheses x minus 2. The 39 is defined for any value for x. Here I can say if this x belongs between, like I mean for x, the domain between 0 and 3 and 2. And this rule will be defined for any x greater than 2. Again, I have this function is called piecewise function because it has two rules. The first one is 39, second one is 39 plus 15 times x minus 2. This will be defined for any value, for any values between 0 and 2. And this will be defined for any value greater than 2. Now, for my questions, the question here is find the value for for number 1, C of half 1/2, and number 2, find for C2, and number 3 for C4. Now, what is the value for C4 1/2? Number 1.
Is it 18.5, I think?
First of all, Shob, you have to check 1/2. Is it in the first domain or in the second domain? Is it between 0 and 2, or is it greater than 2? The 1/2 here.
It's first between 0
Is in the
and
first one,
2.
is the 1/2 is between 0 and 2, is not greater than 2. So because it's between 0 and 2, we have to use this function. So the value for C1/2 is 39 only. Correct, Eric? So the answer here is 39. Now for the second one, C of 2.
Why would half of 39 be 39?
Half of 39, why you wanna use half of 39? Like the function defined here, 39 only. And the function here defined as 39 plus 15.
Oh, any number
times-
between that. Oh, I got it. Got it.
Okay. Yeah, for the second one, C of 2.
It's also
Which
39.
Yes, is exactly 39, because the 2 is between 0 and 2. And the 2 here is defined as equal. You see the equal? We have equal here. So the 2 belong to this domain of the function. So the answer is also 39. So here, C of 2 equal 39. For the third one,
It's second one.
the second one, because the 4 is greater than 2. The 4 is not between 0 and 2. It's not between 0 and 2. The 4 is greater than 2. So we have to plug the 4 inside the second rule, 39. So C of 4 equal 39 plus 15 times 4 minus 2. 4 minus 2 is 2. So here I can get 39 plus 15 times 2. 15 times 2 is 30. So I get 39 plus 30, and the answer is 69. Yes, 69. Any question? Makes sense what we did here? Okay. Now let's go to the net change. The net change. So the net change. So we can here set the net change of the function f of input change from A to B is f of b. This is the formula minus f of a. If I have net change, the net change of the function f of input change from A to B is f of b minus f of a. This is the formula. F of b minus f of a. Okay, so here was like this. This is my A, this is my B. Okay, now I have example. My example. Let the function f of x equal x squared. If I have x squared, my function is f of x equal x squared. The question is find the net change of, so find the net change of, or find the net change of number one from 1 to number 3, and second one from -2 to 2. Okay, find the net change of from 1 to 3 and the second one from -2 to 2. Who will do the first one by using the formula here?
So if
Just
it's f of,
use the, yes.
if it's f of b minus f of a, that means 3 squared minus 1 squared.
Exactly. So the net of change, for the first one is f of 3 minus f of 1. Now the value for f of 3 is 3 squared is 9 minus f of 1, 1 squared is 1. And 9 minus 1 is 8. For the second part, from -2 to 2, what is the net of change?
And that change would be 2 squared minus -2 squared.
Yes, exactly. F of 2 minus f of -2. What is f of 2? Plug inside the function.
4.
4.
4 minus 4.
4 minus 4. And the answer is 0. So the net change of the second one is 4 minus 4 is 0. And for the first one is 8. 9 minus 1. Any question for this, for the net change? Okay, we're going over evaluate another example, evaluate a function. So the example now. Example, evaluate a function f of x equal 2x squared plus 3x minus 1. F of x equal 2x squared plus 3x minus 1. And the question is, number one, evaluate for f of a. Second one, number two, f of minus a. Number three, f of a plus b. And for D, For the fourth one, f of a plus h minus f of a over here over over h. And for the function is f of a 2x squared plus 3x minus 1. We have to evaluate each of 1, 2, 3, 4. Who will do the first one? F of a.
I can try. So,
Yes, go ahead.
since
Just plug
the
inside the
exam,
function. Yes.
so it's gonna be 2 times a squared
2 times a squared
plus 3 times a
plus 3 times a
minus 1,
minus 1.
which
And they give me 2a squared plus 3a minus 1. Correct. For the second one, f of minus a.
Can I do?
Yes.
So 2 minus a squared
Okay.
plus 3 times minus a minus 1.
Okay. Nice. And what is the simplifier for this thing?
2a squared minus
2a
3a
squared
minus 1.
minus 3a minus 1. For the third one, f of a plus b. Just plug inside the function.
2 times a plus b squared
2 times a plus b squared
plus 3 times a plus b
3
minus 1.
times a plus b minus 1. Okay. How we can simplify this?
Isn't it a squared plus 2ab
A squared plus 2ab plus b squared.
Yeah.
Okay. Plus distribute the 3 inside the parentheses.
3a plus 3b.
Okay, correct. 3a plus 3b. So plus 3a plus 3b. Okay, minus 1. Can we distribute the 2 inside the parentheses here?
Yeah.
Okay, let's do it and simplify the answer. What we get is
2a
equal here.
squared
2a squared
plus 4ab
plus 4ab
plus 2b squared
plus 2b squared
plus 3 plus 3b 3a plus 3b
plus 3a plus 3b
minus 1.
minus 1. This is correct. And
Um,
this is, I think it's in the simple way. It's simple already. Yes, go ahead.
Do you have to put you see the degrees to next to each other by any chance?
Yeah, we can put it.
Oh no,
like,
actually, yeah, it's actually in the right form because AB is also the second degree, so it's okay.
Yeah,
I think.
yeah. No, here is second degree. This is 1 degree. We cannot add the 3 to the 2 because here we have a square. Here we have a. We cannot add the 2a squared to the 3a. I think this is in the simple way. Now for number 4, who will do number 4? Number 4 is easy because the number 4 depending in number 3, because f of a plus I think plus h. No, I think this is different, but f of a it's here, so it depending in number 1 only. Okay, who will do number 4? Number 4. F of a plus h minus f of a over h.
So
Okay, who will do it?
2 times
Again, you plug f of, yes. You plug a plus h inside the function. What I get? 2 times, yes, a plus h square plus 3 times what? Shop.
Wait, I have a question.
Yes.
Don't the whole thing has to be inside in the x?
Yes, I mean like a plus h should be inside the x.
Yeah, don't a plus h minus f of a over h, the whole thing have to be under in the inside x?
No, I mean like only a plus h. This should be inside x. And here a should be inside x. Only. Okay, so plug a plus h inside x. What we get? Here, Meisha, she asked or he asked why, because the function f of x, but instead of x, we're going to plug only a plus h. So here, instead of x, we're going to plug a plus h. And if the function f of a, we're going to plug the a instead of x only. Okay, here we get 2 times a plus h, everything squared, plus the 3 times x. X is a plus h minus 1. Here minus f of a. F of a, we do it already here in the first part, f of a. So just we put the minus, open parentheses, and you put everything here. 2a square plus 3a minus 1 over h, everything over h. Now we can simplify the numerator here, the square. So can I get here 2a square plus 2ah plus h square. Now with the 3, I can distribute it inside the parentheses. 3a plus 3h minus 1. And the minus here, I have to distribute inside the parentheses. Minus 2a square plus 3 minus 3a plus 1. Everything over h. But here's something good. The minus 1 and the 1 can cancel. I can cancel the minus 1 and the 1 from now, because I can get 0. Minus 1
It's 11:05, you're
plus
late.
1 is 0. Okay, now we can distribute also the 2 inside the parentheses. What I can get now? 2a square. Okay, let's do it fast. 2a square. 4ah plus 4ah plus 2h square. plus 3a plus 3h minus 2a square minus 3a. Everything over h. Now we can simplify something here. What we can simplify, what we can cancel. The minus 2a with the 2a positive, they cancel out, they give me 0. And the minus 3a, they cancel with the 3a, they give me 0. The only things remain for ah plus 2h square plus 3h. I can reorder it as 2h square plus 4ah plus 3h. Everything over h. How I can cancel the h in the denominator with the h here in the numerator?
With the 3h?
How can I remove this h with the h?
You
What is the
just-
factor for this? Yes, go ahead, Ahmed. What is the factor for this?
The factor is h.
H, exactly. What's
So
remaining here? 2.
it's gonna be 2h plus 4a plus
Okay.
3 plus
Plus
3.
3. And here in the denominator, what I get? Only h. And the h with the h, they can cancel now. So this h with this, done. So the final answer is 2h plus 4a plus 3. Any question?
Oh, sir, I have an appointment.
Okay, you can leave.
Thank you. Bye-bye.
No problem. Now, the domain of the function. Okay, the domain of the function, I'm going to give you, like you talk about the domain of the function is the all possible input, but I'm going to give more example for these things. The domain of function. So the domain of function is the set of all possible input for the function. So the question now, the example, find the domain for each of the following. For the first function, number 1, f of x equal x minus 9 over x. What is the domain here? The second one, g of x equal the square root of x minus 18. Third one, h of x equal x squared minus 3x. Okay,
We can't see the
Yeah.
bottom.
I can see, okay, 3 here. Third one is h of x equal x squared minus 3x. I still do not understand why you include f of a plus h minus f of a over h into 2x squared. You cannot plug everything into 2x squared. Just only the f function. Here we see f of a plus h. A plus h is the only thing you plug it inside the function instead of x. You cannot plug everything here inside the function x. This is not correct. Just you plug the between the parentheses of the function f of f, between the parentheses of the function f, only you can plug it instead of x. You can't plug everything inside x because this is not correct. Here I have the domain. The domain of the function is the set of all possible input for the function. So let's do one by one. First one, f of x equal x minus 9 over x. So this is the first function, f of x equal, number one, x minus 9 over x. Can you go back here? Here you go. Okay. So you should to ask yourself, what is all possible input? I can plug it inside this function and the function will be defined. They will not give me any issue or problem. So you will start from the positive number. Can I plug any positive number like 1 or 2 or 3 or 4 from 1 to infinity positive? If I plug the 1, they will give me 1 minus 9 is minus 8 over 1. And they will give me a value. So correct. What about 2? 2 minus 9, they will give me a minus 7 over 2. And minus 7 over 2 the answer. So I get output. So no problem. If I plug the 3, the same thing. 3 minus 9 is minus 6. Minus 6 over 3 is minus 2. So they give me value. Correct. What about all positive numbers will be defined if I plug it inside this function?
You can't have 0.
No, I'm asking about the positive right now. So I can plug all positive, Ahmed?
Yeah.
Okay. What about the negative numbers? Can I plug the negative numbers here? Minus 1, minus 2, minus 3, or any minus number?
Yes.
Yes, they will not give me any issue. What about the 0? Can I plug the 0 here?
Can't.
I cannot, because 0 minus 9 is minus 9 over 0. And minus 9 over 0 is undefined. Exactly. Undefined. So any number over 0 is undefined. So what is the domain for this function? What's the possible input for this function? I can define it.
Wait, does the real number, what does that mean again? It means
What's the possible input? Can I plug it inside this function?
I know, but can you please explain to me the definition of real numbers again? What does that mean?
The real numbers?
Yeah, what does that mean?
The real numbers is all rational number and irrational number. Rational numbers, I mean like anything of the form A over B. And irrational number, I cannot write it as fraction like this. For example, pi, or square root of 2, or square root of 5, or the third root of 7.
Oh,
So all rational and irrational is the real number. Like also the natural number is real number. Integer number is real number.
so can you say the answer is all real numbers except 0?
Exactly. So I can here say the domain is all real numbers except the number 0. Or I can write it like as mathematically. Like x such that x not equal 0 like this. This is mean x belong to all real numbers, but the value x not equal 0. So the domain is x such that x not equal 0. All real numbers except the 0. Or if I want to write it in different way, I can say from minus infinity to 0, but the 0 not include union. Union mean and from 0 to infinity, like this. All numbers from minus infinity to 0, union from 0 to infinity. And the 0 is not include because we have open parentheses. So we can write it in two ways. The first way is this, and second way is this. Now for the second one, who do the second one? Number 2. Square root of the function is g of x equal square root of x minus 18. What possible input can I plug it inside this function? Can I plug
it has to be 18 and above.
yes, exactly. So actually I'm looking for not I have this here inside this branch inside this radical should be positive or starting from 0 and goes to infinity. This here cannot be any negative numbers. Here I cannot, this cannot be negative numbers. What does that mean, cannot be negative numbers? It means like we learned last time, x minus 18, like we learned the inequality last time, x minus 18 is greater than or equal 0, like this. This should be positive. And we learn how we solve something like that. What we should to do here, I said we have to move all numbers to one side if it's linear. This is linear, right?
Yeah.
We should to move all numbers to one side and all variable to one side. So here we have to add 18 for both sides. I get x greater than or equal 18. So the domain should be all value greater than 18 or equal 18. Makes sense? Again, inside the radical must be 0 and positive, cannot be negative. This is mean here x minus 18 is greater or equal 0. And this is linear here inside. As we learned last time, we should to move all numbers to one side and all variables like x to another side. So we have to add 18 for both sides. Now I get x is greater than or equal 18. And this is my domain. How did you get rid of the square root? I did not get rid of the square root. I found just the domain. The domain, should be here any number positive inside the square root. The square root under the square root should be 0 or positive. This is mean x minus 18 must be greater than or equal 0. Then I solve this inequality like last time. So the domain here for this function, the domain is x such that x is greater than or equal 18. Or if I want to define it in a different way, I can say from 18, and 18 is inside the parentheses, so equal, close, 18 to infinity. Any question? Makes sense, Eric? Again, under the square root must be positive or 0. This is mean it must be greater than or equal 0. Okay, for the last one, h of x equal x squared minus 3x. What is the domain? Third one. Three, h of x equal x x squared minus 3x. What's the domain for this function? Can I plug the zeros here? The zero number? Can I plug in the zero number inside this function? Can I plug the zero inside this function? 0 squared minus 3 times 0, what I get? 0. So I can plug it. They will give me an answer. Can I plug the positive numbers? Yes, I can plug any positive number. 1, 2, 3, 4. If I plug it, they will give me answer. What about the negative? Can I plug the negatives? Also, yes. If I plug negatives, they will give me answer. No problem. So what does that mean? What is the domain here?
All real numbers.
Yes. All real numbers. The domain is R. All real numbers. Any question for this?
How? But what is the domain? Like what? You could just write that.
Yes, the domain is R. All real numbers, or I can write it as from minus infinity to infinity.
I have a question on the
So I
first
can
one.
write it like from minus. For the
Can you-
first one,
Yeah, can you please go back?
yes.
Yeah. Can you also write the
This
domain?
one?
Yeah, you see how you wrote the domain in two different ways? Can you write it in a third way? I'm gonna tell you, but can you just tell me if I'm right or
How?
wrong?
How can I write it? Yes.
So you write uh x is greater than 0.
Like this?
Yeah, and you write, and you also have to write 0. X is less than 0.
Yeah, you can write it like this. But here you have to write it like x such that, like this. X greater than 0 and x less than 0. This is correct too.
Okay.
X greater than 0 and x less than 0. Any question here?
No.
Makes sense? Everything's fine?
Yes.
Okay, so by this, we finished this section, 2.1. We talk about everything in this section. Now we're going over 2.2, the graphs of function by using tables and the plotting point. So 2.2, graphs of function. Graph of functions. Okay. So first of all, what is the meaning of a graph? The graph means curve, like any curve comes from like function after I plug points inside the function. First of all, we have to know that like we have in the book, they starting talking about some different kind of function. So they start talk about the linear function. So here, graphing function by plotting point. Plotting point means we have to make a table and we just choose like random points, plug it inside the function, and then we have to graph a curve. Then we have to graph like sketch a smooth curve between these points. So first of all, the book, like I said, they're starting to talk about types of functions. So the first one, they start talk about the linear function. So here, linear function. So the linear function is any function of the form f of x. Like we said before, it's look like a line equal m x plus b. So what is the m? Anyone can remind me when we start talking about the line? M is a slope. This is correct. The m is the slope. And what is the b? B is the y-intercept. Correct. The b is the y-intercept. So the graph of this function, because here suppose m is positive, like we said before, if m is positive, the graph for this function would be look like this, a line, like line, this form. Line like this. This line has intercept, y-intercept equal b. This is b. Here, this line has m, slope m is greater than 0. The m is positive. This is mean the slope is positive. So this is the linear function. The first function we should to know. The linear function is the function of the form m times x plus b. Second function is the constant function. The constant function is f of x equal like b, constant number. How is the graph for this function? How is the graph of, how is this function look like when the function will be constant? Like when I plug the 1, they give me B. When I plug the 2, they give me B. Plug the 3, B. 3, 4, B. I mean B like constant number. This function will be horizontal line. It is here, it is a horizontal line. It is horizontal line. This horizontal line is y equal b, like this. If b is positive, for example, so it's gonna be something like that. This is my b. B. Okay, the third function is called the power function, f of x equal x to the power n. Here b is positive. B here is positive. And by the way, this is my x-axis. And this is my y-axis. This is my y-axis. And this is my x-axis. The third function is the power function, f of x equal x to the power n. Here, the power function is f of x equal x to the power n. So any function, it's look like a parabola if it's like this n is even, like 2 or 4 or like 6, 8, it will be like a parabola, like a cup. And if it's odd, will not be a parabola, it will be different shape. We're going to talk about this later. Now the fourth one is the root function. The root function is of the function f of x equal x to the power 1 over n, or this is equal the square root of x to the n. This is the root function. Any question for the functions here? Okay, so next time we're going to over example how we can graph function by plotting point. Next time we're going to start for the first example for how we can graph a function by using the plotting point. I will see you next week, and have a good day, everyone.